So the first thing we need to understand is what does uncertainty mean? Uncertainty means when I give you a measurement, first thing you need to realize about any measurement is it can never be, ever, possibly ever be 100% accurate. It can't be, because you could always measure it a bit more accurately, a bit more accurately, a bit more accurately. So nothing can really ever be exactly 42 centimeters. When I write a measurement down as 42 centimeters, what I'm saying is that I don't know, it could be, for example, 42.1 centimeters, all right? Or it could be 42.4 centimeters, or it could be 41.8 centimeters. The point is, all I know to the nearest centimeter, then that it is 42 centimeters. So I'm saying I'm giving you not just the length, but what the how confident I am within that measurement. I know to the nearest centimeter, and so if I've given you that number, then the uncertainty that you can assume, or the range of measurements maybe for this. Let's think about it first of all as range of measurements. It means anywhere between 41.5, because that's the lowest measurement that it could be that would round up to 42 centimeters. So if we say it's going to be equal to, let me just turn that around, going to be equal to or greater than 41.5 centimeters, and that's the x is like the value that it really is, and it's going to be less than 42.5, because anything less than 42.5 would round down to 42. Meanwhile, the one below, now this is saying, no, I know to even more accuracy. So I've got maybe a ruler that has a millimeter line on it, right? So, some rulers have little dashes that show how many millimeters. So what I'm saying here, in fact, why don't you show me the range of measurements for this bottom one now? So basically, anything below 42.05 would round down to 42.0, but there are values that are lower than 42.0 which would round up to 42.0. So we still need to find the minimum value. So let me just do this example as well, because then you'll see what I mean. See, this person is saying that they know to the nearest 0.1 centimeter what the value is. So in other words, the value could be, for example, 42.01 centimeters. That would round down to 42.0 centimeters. But it could also be something like 41.999 centimeters, right? That would also round up to 42.0 centimeters. So that we've got to think about what is the lowest value. So, for example, it could be 42.996 centimeters, right? And that would also round up to 42.0 centimeters. The lowest value would be 41.95 centimeters. That one would round up to 42.0 centimeters to the nearest 0.1 centimeters. So that would the lowest value, and then we could do it like this, and then say, then what's the highest value that would round down? It's a lot easier to visualize the highest value. So that's going to be 42.0, and it's going to be anything less than 42.05 would round down to 42.0. So the next thing is to think, well, how much is this range? The 42, basically, it's not just 42, therefore, but it's 42. So this is how it's actually written, and you might have seen this in the questions. 42 centimeters plus or minus. I'm moving across too far to the right. 42 centimeters plus or minus 0.5 centimeters. Okay. Now, a lot of people might say, well, hang on a second, it's not because it's minus 0.5 centimeters, but it's not plus because it's less than. But it's going to be 42.4. Anything less than 42.5. So pretty much it is just 0.5, and this would be 42.0 plus or minus. This would be plus or minus 0.05 centimeters. So that is the uncertainty. That is, and now this, and more precisely, that is the absolute uncertainty. This bit here, this plus or minus, is my absolute uncertainty. What's the actual uncertainty in units, right? So now the percentage uncertainty means what percentage of the value that I've given is the uncertainty. In other words, what percentage does this value take up? Well, if I actually work that out the way I would work out anything else, 0.5, any other percentage, do 0.5 divided by the 42, then times by 100%. That would give me my absolute uncertainty, my percentage uncertainty. Or, in the case of the bottom one, 0.05 divided by 42.0 if you like, but it wouldn't make any difference on the calculator, and then times 100%. These would give you the percentage uncertainty, right? So the absolute uncertainty is measured in the same unit as the measurements. In other words, the uncertainty is plus or minus 0.5 centimeters, as how many centimeters it could be below or above. And the same with the bottom one. So it could be above, it could be as much as 0.05 centimeters more or less. So that would be the absolute uncertainty in terms of the units. The percentage uncertainty is what fraction of that measurement I've given you there, what percentage of that measurement, the 42, is my uncertainty. So is it plus or minus 5%? Is it plus or minus 1%? What is it? So the way to do that is you take the absolute percentage and you divide it by the value that you've been given as your measurement. So you take the absolute uncertainty here and divide it by the 42. And then that would give you, well, let's just do that on the calculator. So when you put them into the calculator, you're going to get plus or minus 1.2% or plus or minus 0.12%. And you can imagine that if the absolute percentage was plus or minus 0.5 centimeters, that's going to be a much smaller percentage for larger measurements. So let's say my uncertainty for this is 0.5 centimeters. In fact, I'll do a proper example of this. So I'll demonstrate an experiment which you see in GCSE papers as well. Actually, let's say we're going to measure the wavelength of some water waves. Oops, that was very wobbly. Let's try that again. Right. So in fact, what I'm going to do is I'm going to take that, I'm going to rotate it, and then I'm going to squash it down. Okay, so let's say I've got these water waves here, and you say, how would you go about measuring the wavelength? Well, the wavelength is between any two identical points. I've got a ruler that measures to the nearest millimeter, so it has an accuracy of plus or minus 0.05 centimeters. That's not my accuracy, my uncertainty. Whatever measurement I'm going to get is plus or minus 0.05 centimeters. And if I measure that and I get, let's say, 5 centimeters, or let's say 5.2 centimeters, then the uncertainty would be plus or minus 0.05 centimeters. So why don't you first of all go ahead and work out what the percentage uncertainty is in that case. All right, so if you do 0.05 divided by 5.2, you should get 0.96, right? So we could rewrite that as 5.2 So plus or minus 0.96%. That's fine. Okay, quite a small percentage actually, not too bad at all. But could we do better? So let's say what would happen if we measured. We could take a different measurement. We could take a different method, and we could measure all of this all the way down to here. And we could then divide it by how many there are. So we've got 1, 2, 3, 4, 5, 6, 7, 8 wavelengths. And let's say that we measured, we got the same value. So so we got the same value. So it would be equivalent of 8 times 5.2 centimeters, which would be equal to 41.6. It's still plus or minus the same 0.05 centimeters. But let's go ahead and work out the percentage uncertainty this time. So when you work it out in this case, you're going to get the percentage error is actually plus or minus 0.12 percentage. So you get a much lower, you get the same absolute percentage because we got the same ruler. We still know it's that much degree of accurate uncertainty, but now we have, in terms of what percentage of my measurement am I uncertain about, I've got a much lower percentage. And we kind of learn about this before we even learn about how to calculate percentage uncertainty. We know that if we're measuring, if you think about it, if we got a stopwatch and we want to measure how long it takes for somebody to run a marathon, then the measurement that we're going to get is going to be pretty accurate, right? We're not going to be out by much of a percentage. Whereas if we measured how long it takes for a ball to drop from 1 meter, when we're going to do that with a stopwatch, we're really going to be way off, because our uncertainty in that case would be down to our human reactions and so on. But that uncertainty is going to have a much smaller effect on a marathon than, because it's a larger duration of time compared with a ball dropping. So absolute uncertainties will obviously have a much smaller effect on large values compared with on smaller values. And this really is just how to actually calculate that. Okay.